We welcome our next keynote speaker, Sayon Sasha, founder, data science partner, and manager at Delivery Hero. He was an ML engineer and a data scientist at Trivago. He was actively involved in volunteering at Dusseldorf Data Science Meetup and is certified with AWS in machine learning, specialty certificate. This talk focuses on the challenges in running decision science experiments with humans involved and embracing learnings from iterations, how to best utilize limited data caused by stochastic activities, how to consider region-specific operational constraints on a global scale, how to tackle unclean data due to on-ground human error in warehouses. Answering such questions strategically enables designing hypothesis validation setups, which differs from doing it on traditional web applications. This talk discusses how to draw insights while navigating uncertainties and to leverage the outcome for optimizing operational decision-making processes. Thank you, Sayon. The stage is yours.
Thank you so much. So, hello everyone. I'm Sayon. Thank you for the introduction. I work as a data science and engineering manager with Delivery Hero in Berlin. Today we are going to talk about how lean experimentation looks like when you are doing a new feature or a new product in warehouses, and what role does decision science plays there. Before we start, this is how we're going to talk about. First, we will touch about the why, what, and how of the problem itself. What about operation research? How does operation research play a role in the chaos of inventory systems? And then touch upon the different stages of lean experimentation, followed by how decision intelligence also plays a role there. Before we go into the why, the purpose of what we do and why we do it, do we have anyone in the room who uses Glovo here in Belgrade? Yeah. So I think that should be bringing a bit of familiarity that you use Glovo to order in food from restaurant or from groceries, and this is where it boils down to what we do with scheduling pickers. Now, the how part of this is something we will discuss. And this is what brings the why or the purpose into the life. And then also the what part, which is often easy to determine, but that is what leads into the how and the why part of it. Big picture, quick commerce. What is quick commerce? As the name suggests, it's basically fast e-commerce, fast traditional e-commerce, as we were talking about what Glovo is doing in Belgrade. And typically, the journey starts from the customer ordering something on their app. Then there is a warehouse, or how in Delivery Hero it is called DMart. The warehouse somewhere in Belgrade receives, based on where you are ordering it from, goes and receives the order. And then there are pickers who have an application on their device, and they go and start picking these orders. Then once the orders are picked, riders come in. This is where the delivery happens. And then it reaches the customer, and all of this ends up happening within less than half an hour. So that's where the main challenge comes in with e-commerce, that you don't really have the time to prepare. You have to do everything very fast and be very agile. Now, where does picker scheduling fits in here? So you can imagine this is a warehouse where the order is received, and if you do not have optimized picker schedules, if you have too many pickers or if you have too less pickers, you either lose orders or you increase your operational costs. So having an optimal number of picker shifts in this scenario is very important for order fulfillment. And that's what one of the key factors. There are several factors, but this is one of the factors that leads to efficient and fast grocery delivery at your doorstep. Now we come to the how part. How do we do the picker scheduling in this context? So as you can imagine, a lot of data goes in to determine how many pickers do I need next Monday in a particular neighborhood in a warehouse in Belgrade. Now, one of the key factors that leads to this is the customer order forecast, which is you determine basically based on the past historical data. Next Tuesday, 10 to 11 a.m., I'm expecting 100 orders in this DMart. It might be different in another DMart. And this is where we are using time series algorithms, stacked regression, to come up with a forecast for the next n number of days. How many days? That depends on the use case and the context. Of course, the longer you forecast, the lower the quality gets. But yeah, it depends, because you can imagine for picker scheduling, the store manager often needs to schedule pickers for the entire week, or also at times for the entire month. So that way you need to do it quite early. The next thing that comes in especially for the this domain of inventory management, is the picker just doesn't do customer order forecast, customer order picking. They are doing a lot of other inventory activities. For example, cycle count, keeping a track of how many cola do I have? Do I need more milk? Then it comes to receiving. So from the supplier or from the distribution center, the stores and the warehouses are receiving purchase orders and receiving store transfers. And these things needs to be taken into the inventory, also a function of how much orders you are selling. But basically, you need to take this also into account. And then apart from that, there are also quite a few activities like, for example, cleaning, or regularly checking the temperature of the fridge, or something else that come up. Basically, they are the ones running the warehouse, the operational activities in the warehouse. And then the third set of data that we need to take into account is regional regulations. So before I mention this, it's good to mention that the operating model, how it is working with Delivery Hero, is right now we are having around 800 warehouses across the globe in 70 plus countries. So that means we are always taking into account regional constraints. So you can imagine the break timing regulation in Istanbul will be very different from the break timing in Austria. Or the shift length. Do you work for 4 hours, 8 hours? That's very different in Belgrade versus in Singapore, for example. So these are also certain region-specific, warehouse-specific, only to mention a few assumptions that needs to be taken into account. Now you can imagine you combine all of these data, some coming from machine learning, some coming from more probabilistic estimations or data analysis, and some coming as assumptions. And then what we do is we feed this into a linear optimization model. So in linear optimization model, basically there's a model out there which uses mixed integer programming, and it decides that next Thursday in the morning, if I have, or next Thursday throughout the day, if I have 1,000 man hours demand, what is the optimal number of shifts that I'll recommend? And how should that peak look like, depending on the hourly or the half-hourly demand that we generate. And this is what results into a picker shift or a picker schedule. So what the warehouse or the store manager receives at the end from the central team in Delivery Hero or Berlin is basically you have the demand forecast, you have the picker forecast, and then you have sets of shifts defined for that picker, for that warehouse. And based on this, the store manager can decide how to move around the pickers in between among the different stores in a given region, or also over the months, whether to hire more pickers or whether to reduce the number of pickers. So that helps with a lot of decision making for the data-driven decision making for the warehouse itself. Now, where does operation research come into the picture? We spoke a little bit about linear optimization, but basically operation research is the scientific approach with which you try to find an optimal solution to a business problem, which otherwise would be impossible to find. And one example of that is what we saw before this, the linear optimization of the demand that we forecast. And there are basically, across the globe, there are basically two kinds of inventories that we tackle. One is the warehouse, which is a bit more organized, and users do not usually, normal customers do not usually just walk in. But you also have the local shops where the normal customers can walk in, but also the pickers of Glovo or any other pickers of any other entity of Delivery Hero can also just walk in. And this is more disorganized, but you also get fresh products or meat or more fresh fruits and vegetables and these kind of things, flowers and anything and everything. So this is where operation research comes in to take care of this chaos, because we are dealing with a lot of deterministic as well as a lot of stochastic activities out here. Now, basically this comprises of these three domains that work together: inventory management, supply chain management, and then there is fulfillment operations. So all of these combined together takes care of the end-to-end movement of the raw materials, the goods, the product across the warehouses. And while doing so, pickers play a very important role, and that is why we are talking about picker schedule optimization. And where does the chaos come from? So on the right, we have this, I put it on Dream AI, how warehouse inventory for warehouse. And I even put the word chaotic warehouse for inventory, and this is what came up. And last summer when I was in Istanbul, this is how the warehouse looks like. So there is a lot of chaos around, and we have to deal with it. Of course, you can build way more applications over the time to collect more data, to organize things, but we cannot wait till that point in future. We have to do things on the way. So what are the complexities that come up? One thing which comes up doing experiments in warehouse compared to any other traditional application or warehouse is basically the high uncertainty and randomness. We speak about receiving products in a warehouse. Now, certain regions have a good schedule for DCs, for distribution centers, that the truck would arrive every Tuesday and Thursday between 10 and 1 p.m. But that's super unrealistic. The traffic situation is different in Austria versus in Argentina. And things happen. Things don't happen on time. So the way we look at it is, for these kind of activities, look at the recent data points, try to find out a pattern, scope them as much as possible, and then go ahead with that till we have a better solution. So in this case, for some of the countries, we already have some information around scheduling of how the receiving process happens in a warehouse. But for some countries, we don't. Then there is low data quality and reliability. And this comes from the fact that there's a lot of human beings involved in this process. You are not running an experiment on a website that you will have all the data on your log for whenever someone is clicking on a button. So what helps here is more listening than measuring. So focusing more on quality surveys, focusing more on quality feedback with more close-ended questions for the people in the warehouse to gather that data, which you cannot possibly do it quantitatively and get it onto your database. And of course, one of the continuous process is, as a company, invest in data collection infrastructure. That's always an ongoing process, but the point is, what do you do when you do not, till the time you don't have that? Then there are biases. Talking about, we have human beings around, so there are, of course, biases. And we are talking about 70+ countries with more than 1 million riders and partners. This is kind of the scope when you are building a solution here. So the first bias that comes in is cultural difference. An example of it is, we have this product in the application that when something is out of stock, the picker gets recommended for a replacement that they can send. And the difference is that for example, in Singapore, if soya milk is out of stock, maybe some other kind of milk will be recommended, and the picker directly sends this to the customer. But in Istanbul, for example, pickers don't do that, customers don't like it. Rather, the picker every time calls the customer that, hello sir, hello madam, I do not have soya milk, the app is recommending this other milk. Are you okay with that? So there is a difference. And then when you look at for example, the picking time that is being logged into the database, picking time is drastically different into different regions. And why is that happening? Is it because the pickers are being lazy? No, there are these things which are not really logged in anywhere, and you only know it from visiting the DMart and doing more qualitative surveys. Then there is, of course, on-ground human bias. It's kind of related when you are getting a picker schedule and you want to decide how you want to go forward with it. And then there is seasonality bias. And this is also something taken care of by the different time series modeling that you do. But you are not only talking about a geographical space, but you are also talking about throughout the year. And certain things can be predicted, certain things cannot. When we do the customer order forecast, it takes into account, for example, public holidays, festivities. But for example, if Argentina would go into the World Cup final or not, you cannot predict that 2 weeks in advance. So that particular day, the customer order error would be super high. And this is something we need to deal with. Now, what are the strategies? There is no silver bullet here. We have to embrace the chaos, and we need to define from a product perspective what are the things we can and we cannot do. What becomes important is whenever we are running such experiments, it is very crucial to define the start and the goal value of any measurement that we are doing, whether be it desirability, if my end customer wants it, how much do they need it, feasibility, what I'm promising, is it at all feasible and sustainable to do it, and also viability. And then it's also important in these scenarios to differentiate between what are the initiatives you would already take proactively, what are the ones which you foresee probably an issue, and you wanted to prevent it, and so you take action. And there could be also things for which you don't do either of them, and you wait for the disaster to happen, and then you react. Maybe that disaster happens once a year, and then we go for a more reactive approach. These are more the product strategies. When it comes to the mathematical or the data science modeling strategies, there's a lot of, traditionally, if you go into warehouses, there's a bulk of Excel sheets where the store managers are managing Excel sheets. So one of the major things we try to do is to move away from that Excel sheet approach and go into more probabilistic simulations, go into more quantitative optimizations. This book that's mentioned here is quite useful and handy for the data scientists to deep dive who are more interested into knowing more about the different complexities of multi-echelon supply chain management problems. And yeah, it's quite helpful. Now we come into lean experimentation. So we spoke about why, what, and how. We spoke about the challenges. Now say I have built a small MVP of taking all of this into account, small MVP. Does it work? So typically, it starts with build, which is we need to map all the data and the assumptions we have before we start conducting the experiment. Once we map and put together all the data and the assumptions, then you basically execute the experiment and you measure. And then based on if you validate, if you accept or reject the hypothesis, then you basically decide, okay, I accepted the hypothesis. Should I go ahead and implement this and make it a solution? Or reject it, let's log the learnings, fail fast, learn fast, and move on to the next cycle of experimentation. There are various experimental designs out there. Not one fits every problem. When it comes to running this kind of experiments on the warehouses where you're actually dealing with people and human beings, we tried different approaches with variations of A/B testing, segmenting warehouses into control and test group, and then going forward with rolling out the picker schedule in some of them and not rolling out, and then seeing what is the difference. Is the automated approach doing anything better than the human approach? Lean hypothesis testing, which we will touch upon it in the next moment. And then there is focused group user testing, which is what I was talking about, that at times it becomes important to listen more than measuring. Having a focused group of store managers or users of warehouses and rolling out qualitative surveys for them with close-ended questions to gather the data. At the end of the day, it all boils down to, did I have enough evidence to make my null hypothesis look ridiculous? And there the team does a lot of statistical tests, decides on the p-value, and decides if to go forward or not. But this is also where decision intelligence also comes into the picture, that how do you decide if this is good enough for me to productionize, or let's rerun another circle? Let's look into how a hypothesis looks like. So developing a a smart hypothesis is very important, something that is measurable, something that is time-bound, something that is more tangible, and something at the end of the day, basically, it should be actionable. So for the case of picker scheduling, like an example of a suboptimal hypothesis would be, my hypothesis is, I have built a picker scheduler, and whatever schedule I'm providing, it is good enough, something like this. But what is missing here is we specifically need what element are we testing, the current and the proposed methodology, the constraints that we need to take into account, and the KPI, the key performance indicator. So in this case, how does it look like? So for this one, the example would be, I want to change picker shift schedule from manual heuristics approach to a more demand forecast optimized approach while sustaining the customer experience. So that means just to reduce operational cost, I cannot just reduce the number of pickers, then I will lose orders. So the customer experience needs to also sustain. So this kind of change from to while keeping something constant, this helps a lot to frame the hypothesis. And then comes the next part of the hypothesis, which is doing this, what will it lead to? It will reduce the operational expense. That's my key performance indicator here. And operational expense can have several sub indicators, like, for example, optimizing the daily man hours, or diminishing the picker idle time, or boosting the picker utilization. Now, with this approach, with this new schedule, the utilization rate of the picker is much higher, for example. And when we reject or accept hypothesis, then we have to go through to check if each of these match, and even have a start and an end value here, that my start value of the operational expense is, I don't know, X euros, and I reduce it to Y euros in a span of 1 month of experimentation. So yeah, in a nutshell, with the experimentation, this is the key takeaway. And what helps from our experience is, when it comes to such business problems, any kind of big data experience, intuition is just not enough. You have to run scientific business experiments, and you have to define your decision criteria before you run your experiments in order to validate them if it is worthy enough to go and roll it out or to build a solution for it. Moving on to the last section, decision intelligence. So this is a topic that also plays a very vital role when navigating so much of uncertainties with less reliable data. How do you take decisions at every step? And this is not just applicable in this context, applicable in several other contexts, but especially with experimentation in warehouses, where you have a lot of humans in the loop with so much of biases, making good decision with a scientific framework becomes very important. And what you end up having is, when running these experiments, you have data overload. You also have decision overload. You end up making n number of decisions, where certain decisions are a result of some other decisions. And it's basically, at the end, it becomes like a decision tree that you need to do. And you want to make the most optimal decision. So decision intelligence is basically more than this or that. It's basically a scientific framework which augments data science. And it augments data science from the different fields. It augments it from the field of social science, decision theory, managerial science. And the next couple of slides, I actually took inspiration from the data, from the decision intelligence content that Cassie has online. She presented in the keynote this morning. And some of the key takeaways for me I would like to share here, which were also very much applicable when running such experiments in warehouses. The question that it's good to start with is, what would it take to change your mind? We already have decided, when you are building a picker scheduler, it's kind of, you're already pre-defining a criteria that I'm building a scheduler because on ground they do a bad job, and I will do better job than them with data. May not be the case. One of the biggest pitfall here is you will always be biased towards being this experiment successful because you are building it, you are putting in so much effort. And how do you go ahead with that? So there are a few biases that I would touch upon which are important to keep in mind, like while making smart decisions during experimentation phases. One is good decision leading to bad outcomes does not necessarily mean the decision was bad. So it's important to maintain a decision log and to go back and check what were the circumstances or the criterias in which you decided to accept or reject an hypothesis. Does that still hold for this another region or another geographical area where you are working? If not, let's not correlate decision with outcome. Then all of us, most of us are aware of confirmation bias. What I was talking about right before, that very often we formulate our decision criteria before even viewing the data analysis results. So it's more like coming from my experience or my opinion. I'm not saying opinion is not important. Experience is very much important, and those fundamentals are very crucial to drive forward, but also not to already make up your mind before doing the data analysis of the experiment. The other thing is around clairvoyance. And this is a bit opposite of being data-driven, is there are times when you need to access your intuition to optimize heuristically, especially when navigating such uncertain world of supply chain management and inventory optimization. There will be moments where we need to take certain decisions based on experience, based on intuition, and that's perfectly fine. We have to compromise perfectionism going forward at some point during the experiment phase. The last thing I want to touch upon is, here I'm assuming, for example, you are the owner of an experiment that you are running, and you have a team. You have data engineers, data scientists, you have data analysts, statisticians, etc., etc. Now, when do you leverage what? You cannot go for a machine learning solution everywhere. You cannot go for one-stop solution for everything. So for this, what helps is to look at it this way, that how many decisions are there in your experiment at this moment? If you do not have any decisions to make right now, go to your data analyst. Because what data analyst does is basically, it's like a new sensory organ. It gives you the power to ask more insightful questions. It gives you, you do not have any valid questions to ask right now, but with data analysis, you get the ability to find those right questions that you can ask, which you can probably reject or accept by running a lean experiment. Then, for example, you have few decisions to make. In this case, any guesses whom would you go to? But it's just few decisions. In this case, you would rather go to a statistician. I mean, I'm not saying you won't go to a data scientist. Maybe it could make sense to go to a data scientist. But actually, when you have only one or two decisions to make, statisticians help you taking that subset of data, extrapolating it, and giving you that rigor and confidence to go ahead with the decision. Because you don't have 100% data, you have 30% data. And that 30% data is a good enough sample size to represent that 100% data. So that is where statisticians come into the picture. Where does data scientists come into the picture? It's when you have many and millions of decisions. And that's where data scientists actually helps you create a model where you can automate the decisions. You have a million decisions to make, and you cannot make those decisions by yourself or with a statistician or with a data analyst. So there you create a model that automates these decisions for new data points, unknown data points that you have not seen before. What is good to keep in mind is, as an experiment owner, you still decide your objective function. The function that you want to optimize for your experiment, that's still your decision, and you need to define it before you go to a data scientist for this automated decision model. Because at the end of the day, the function that you want to optimize that's very closely related to the business problem that you are trying to solve. What do I mean by negative? In this case, it's basically you don't need to make a decision and you already have an answer. And this is a common pitfall that we often, when we already have answers, we often use data to just confirm our decision. We already can take a decision without the data because for whatever reason, be it experience or bias, we already have a pre-made decision. And it's a waste of time to run an experiment just to prove to your, I don't know, to your stakeholder or to your leadership that this is what it is by taking help or taking support of the data there. I think that's it. I think we covered a bit of various aspects, starting from different types of lean experimentation, going into the more how picker scheduling looks like in warehouse, and then also the importance of decision science in such a setup or such a scenario. Yeah, thank you everyone. I'm happy to take any questions if you have.
Thank you, Sayon, for this very amazing and insightful talk. Here's your certificate of appreciation. And that is it for today. Thank you, everyone. I hope that you found the talks both informative and enjoyable. Your presence has truly enriched our conference. We look forward to continuing our talks and furthering our collective knowledge tomorrow at 9:15 a.m. Thank you once again. Have a pleasant rest of the day. Thank you.